Welcome back to my 7th grade advanced class. Let's knock out 4.1. We're talking about similar figures here at the beginning. It says find x. Well, we see that we have 3 and 2 over here and 8 and some number over here. I know I would have to multiply 2 times 4 to get 8. So that means I would have to multiply 3 times 4, and that's going to give me 12. So write and solve a proportion, use cross multiplication. I see that I have 2 to 3, and I'm going to have 8 to x. This means I'll take 2 times x. That has to equal 3 times 8, which is 24. Now to separate 2 from x, that's going to give me 2x divided by 2. Whatever I divide from one side, I divide from the other. I'm going to fill in the blanks here. So this is going to be divided by 2, which means this gets divided by 2. 24 divided by 2 is 12, so the height of the triangle is going to be 12. All right, let's go ahead and move on to number 3. Number 3 says find the sample space and the total number of possible outcomes of the indicated event. All right, so the possible outcome says choosing a toothbrush. All right, I'm choosing a toothbrush. It says type, electric, and traditional, and the strength is extra soft, and medium. Okay, so when we find a sample space and the total number of possible outcomes, we have to remember we're going to make an organized list. First, you can have electric and extra soft, right? You could have electric and soft, and then you could have electric and medium. Okay, then you could also have traditional extra soft, traditional and soft, and traditional and medium. So there are 6 possible outcomes, all right? So they said to find the sample space, this is my sample space, and the total number of possible outcomes, 6 possible outcomes. All right, let's go to number 5 next. The 5 says using tools to draw triangles, use geometry software to draw the triangle with the given side lengths if possible. Okay, well, we're not going to use geometry software. It says to draw the triangles, the given side length if possible. We can't give everybody that software at home, so I'm afraid this isn't going to be possible. If we're doing this, we're just going to do it by hand here. We got 2, 7, and 9, which tells me we'll have 2, we will have 7, and it says 9. And now we run into trouble. Now, the reason we run into trouble is that the side lengths are 2, 7, and 9, or 2, 7, and 9. And remember, we need our 2 legs to be smaller, okay? My 2 legs have to be smaller than my 3rd leg. And this is why. I'm just going to erase what I had here now that I realize there's no way to do this. If I take 9 and put it across, and I take 2 and bring it all the way over here, okay? Then I bring 7 and bring it all the way over here. Well, guess what? 2 and 7 make 9, which means I would have 2 and 7 laying flat on top of 9. It would not make a triangle. So when they asked us to draw this with the given side lengths, if possible, we have to say no, this isn't possible, because the 2 side lengths that are shorter have to be greater than the length of the 3rd leg. So not possible. 2 plus 7 equals 9. All right, let's go to number 7. Number 6 was yours. Identify side lengths to identify triangles. Determine whether the side length forms a triangle. I have 16, 21, and 27. Can these form a triangle? It said to determine whether the side lengths form. Yeah, because I've got 16, 21, and 27. 16 and 21 are smaller when I add them together, or actually bigger when I add them together than 27. So yes, 16 plus 21 is greater than 27. All right. 21 plus 27 is less than 16. And 27 plus 16 is less than 21. On number 9, sorry about that, kind of jumped the gun there. It says, can it be a triangle? We have 6, 1, and 5. Again, just like with the problem that we had, I think, in number 5, if I take 6 millimeters, and then I go ahead and I take 1, and I take 5, they're going to lie perfectly on 6. There's no way to make a triangle. So this answer will definitely be no. You cannot make a triangle with those lengths. So no, 1 plus 5 equals 6. All right, we've got number 11 next. You be the teacher. Friend wants to determine whether the side lengths 11, 43, and 55 can form a triangle. Is your friend correct? 11 plus 43, according to your friend, is less than 55 centimeters. Because the sum of the two lengths, the two triangles, is not greater than the length of the third side, you cannot form a triangle. Well, that's absolutely right. The sum of any two sides must be greater than the length of the third side. Since 11 plus 43, those together make 54. 54 is less than 53. So these side lengths cannot be used to create a triangle. Let's go to number 13. Draw a triangle with the given side lengths if possible. Well, we have 10, 30, and 50. Once again, 10 and 30 are not bigger than 50. They're less than 50. You cannot make a triangle with this because you'll not be able to connect them. So not possible because 10 plus 30 is less than 50. On number 15, we got 8, 12, and 13. Yes, you can do this because 8 and 12 make 20. 20 is greater than 13. So 15 is yes. All right, and a triangle would look like this. All right, let's go to number 17. You watch a rocket launch at the Kennedy Space Center at a distance of 5 miles from the launch pad. Okay. See, a distance of 5 miles from the launch pad. Okay, let's just check that out for a second. Okay, we're 5 miles from the launch pad. Now this says in the first 60 seconds after launch, the rocket travels 11.5 miles from the launch pad. So they're saying this is going to be 11.5 miles up. All right. Describe the possible distance between you and the rocket after 66 seconds. Remember, you're 5 miles from here, right? And we're having to find out how far you are between you and the rocket after 66 seconds. And remember, 66 seconds is how much time this went. So we have 11.5 minus 5. Now, remember, we have 11.5 here. We're going to take away 5 miles, okay? That's going to equal 6.5. Now, 11.5 plus 5 is 16.5, okay? So you might be saying over here, Mr. Mendez, you subtracted 5, and over here, you added 5, right? Now remember, you watch a rocket launch at the Kennedy Space Center at a distance 5 miles from the launch pad. In the first 66 seconds after the launch, the rocket travels 11.5 miles from the launch pad. So describe the possible distance between you and the rocket after 66 seconds. You could be, since this is a distance of 5 miles from the launch pad, you could be, let's see, taken away 5, or you can add 5. So the distance must be greater than 6.5 and less than 16.5. Okay? The distance must be greater, okay, than 6.5 and less than 16.5. Are all distances in part reasonable? Explain. Yes, the rocket could be flying away from you, or it could be flying towards you. Okay? All right, let's go ahead and check this out here. We're going to number 19. Determine whether you can construct one, many, or no triangles with the given description. So there's an isosceles triangle with side lengths of 4 feet and 1 foot. All right, can you construct one? Let's go ahead and look at this information that they've given us. An isosceles triangle has 2 sides that are the same, right? And then a third side. Could be like this. I mean, it really could be one that looks like this too, long as the 2 side lengths are the same. So it says with side lengths 4 feet and 1 feet. So you could have a 1 foot here and 4 feet here. So can you make a one, many, or no? I'm going to say you can make one type of triangle with this. Okay. Let's just check and see if that's true. 1. An isosceles triangle has 2 congruent sides. In this case, the missing side must be 4 feet to satisfy the condition. So this was 1 foot, the other side was 4. In other words, we would need 4 feet on this side. Okay? Now we've got number 21. 21 says, make a connection. The triangles are similar, so we know they're similar. Find the possible lengths. For the missing side, explain the reason. Over here, we got 6, 8, and something. Here, we got 3, 2, and something. All right, so we got X and we got Y, okay? We need to find the possible lengths. Well, by looking at this, if they're similar, the small one here has to be, right, proportional to 2. That means this second to the longest one here is going to have to be 6 and 3. And then this longest one here is going to be 8 and X. I can tell you from 3 to 6, this is a multiple of 2, because 3 times 2 is 6. So if I have 2 over here, that means I'm going to have to multiply it to 2. Y, I believe, is going to be 4. And then if this is 8, since I'm multiplying everything over here by 2, I can divide this by 2. X should be 4. So because the triangles are similar, there is a constant proportion, right? A solvable proportion using cross multiplication. Just like I said over here, if I have 6 to 3 and I have 8 to X, 3 times 8 is 24. 6 times X is 6X. When I divide 6X by 6, I divide 24 by 6. That gives me 4. X equals 4. And now let's solve for Y. I said that if 6 is to 3, then that means Y is to 2. So I'm going to have 3 times Y is equal to 6 times 2. That's 12. When I divide 3Y by 3 to get Y by itself, I divide 12 by 3. And 12 divided by 3 is 4. Missing lengths are 4 centimeters and, well, 4 centimeters. Let's go to number 23. 23. A triangle has fixed side lengths of 2 and 14. How many triangles can you construct? Okay, remember, says a triangle has a fixed side length of 2 and 14. Okay, so, all right, we can have 2 here, right? We could have 2 here, we could have 2 here, we could have 2 here. So how many triangles can you construct? Use the figure below to explain the reasoning. It says each point on a circle is the same distance from a point called the center. Well, oh, I forgot this 23. So that was, yeah, this one's still for me to do. All right, hold on. Sorry about that. I had to tend to something. Now, um, it says each point on the circle is the same distance from the point called the center. So you can construct an infinite number of triangles at every point except 2 on the circle. Another third side of the triangle can be constructed. What are they talking about when they say except 2? Well, if the 2, I'm trying to find my dot here. Oh boy. There we go. All right, if the 2, we've been coming here, what if the line actually sat right here? Well, that would not make a triangle, would it? Because that would be a line on top of a line. That doesn't work. The other way is if 2 was over here. Or if the, yeah, this was it. And then again, I'd have a straight line, right? If this was 2, or this was 2. So except for those 2 spots, you can have an infinite amount of lines, right? Coming from here. You can slice it more and more and more and more, right? And every one of these would make a triangle. Let's try B. Is the unknown side length of the triangle also fixed? The length of the third side changes depending on where the 2-unit side meet in the circle. Okay? So we're talking about depending on where these 2-unit side lengths, okay? The length of the third side changes. If it's over here, it's going to be longer, right? Let me erase this so you can see what I'm talking about there. Oops, sorry about that. I did not press the eraser. There we go. So what they're saying is, if it's over here, right, this third length, this is still going to be 2, but the third length is going to be shorter because it's close. Shorter than if it was over here, where the third length would be much longer, right? This side would be shorter. And I know that's a horrible line, but you know what I'm trying to do here. All right? So let me erase this. So I think that's all of them for me. Yep, looks like the rest are for you. Good luck with your homework, and I'll see you in class for